Let's look at transforming exponential functions. First, we're going to look at the parent function here. And the parent function looks like this. Now, let me show you what happens, why it's that way. We get this simple, short little x1 table. And I'm going to use both sides of the x-axis. Starting with 0, and let's put 0 in. 2 to the 0 power, anything to the 0 power is 1. And if I put this one in, 2 to the first power is a 2, and 2 to the second power is a 4. Well, when it's a -1, that brings the number and exponent to the other part of the fraction and makes it a positive exponent. So that's 1 over 2 to the first. So that makes this 1/2. And then 2 to the fourth, but it's 1/4. So we'll graph those as first this one, and that would have been 1, and I probably should have had it more up there, and 2 to the fourth. In fact, I'll go ahead and fix those. Let's make this a little more like that. The other ones, it's harder to tell anyway. 1/2, 1/4, you just know you're getting closer and closer to 0. So the characteristics of this is that it has a horizontal asymptote at 0, y equals 0. No vertical asymptote, because this keeps on going over this way as it goes higher and higher. And that's what happens. Let's look at the trend in this, is that it moves as we always go from negative infinity to positive infinity. Like when we read, we go in this direction to the right. And so what it is that happens here is description of it grows very slowly at first, then starts growing faster and faster. That's a basic generalization of what happens there. Now we're going to look at transformations of it. We'll start off with where we have an x plus 1 in the exponent. Well, and I'm going to show the difference for that by putting it in a simple xy table. So now it needs to be a -1 up here. 2 to the -1 plus 1 is 2 to the 0, which is a 1. So notice that we went from 0 to 1 to get the 1, which places us here on the, let's see. But we didn't put 0 here. Let's see, that's -1 and 1 is where we're at. Approximately there. If we put 0 in there, we get 2 to the first power. So that means we're actually going through the y-axis here. Okay. Now, this one's a little bit below. This is misleading when you get really up close. So let me do this to sort of show that the parent function comes down and it hits here. I think I erased too much. And then it goes to 1/2 here. And the second one is going to 1/4. So when I get up close, it's supposed to be going this way. Whoa. Okay, so these ones I can get away from it, which means this one, you can tell is going to be going on the inside here, and it's going to be going just slightly above the other one. Okay, and actually I meant for that to be in blue, full on blue. But good enough. That's going to look good. Maybe I'll leave it in the red to show the difference. Okay. Now the other numbers that are in here. Okay, if I put 1 in here, I get 4, and 2 in here, I get 8 to the third power. Here, -2, that makes it a -1. It makes this just 1/2. Right, so what happens with this is when you add 1 here, that means we're moving to the left 1 spot. Okay, moves 1 unit left. That means this one will be the opposite. This one will move right 1 unit. And now I don't even really need to show at 0. If I put a 0 in for the x, when the x is 0, I get 2 to the -1, which is a 1/2. And then 2 minus 1 is 1. So that's where it is here. So what it does is it's going to be on the outside of it. As we go up further, it's going to be a little bit on the outside. And even farther in between, getting closer to 0. So it moves 1 unit right. Okay, let's fix this and then move on. Here, the 1 and -1 on the next one is on the outside. And what that does, watch an XY table for this. Okay, -2, -1, 0, 1, and 2. Okay, so 0, 2 to the 0 is 1, plus 1, we're at 2. And then -1, 2 to the -1 is 1/2, so it's 1.5. And then -2 is -4. Okay, is 4 to the 4th power, but now it's on the bottom, so it's 1/4, plus 1 is 1 1/4. But in this one, that's 1, 2 plus 1 is 3. And then if I put a 2 in there, that's 2 squared is 4, 4 plus 1 is 5. So let's graph a couple of those. Okay, that one. And at 1, we're at 3. And at 0, we're at 2. And then we're at 1.5 and 1.25. So this is going to be just above that line, and it goes up here. Okay. So in this case, it looks almost like the same as moving 1 unit left, but what it is moving up 1 unit. Moves 1 unit up. And the other one is the exact same thing, but now it's going down. And I'll even just write that first. Moves 1 unit down. So now, for the parent function, that comes down 1. That's going to come down 1. That's going to come down 1. So it's going to go on the outside here. And there's an asymptote of -1, horizontal asymptote of y equals -1 instead of 0 this time. And above, it's a horizontal asymptote of +1. So these numbers actually, in these cases, become the horizontal asymptotes. Okay, so and let's go on. The parent function again is going to look approximately like this. Now, what happens here when we multiply by 2, and then we'll go look at multiply by 1/2. Okay, so this one's a stretch. And if we would do a simple XY table here, so 0, -1, -2, 1, and 2. 2 to the 0 is 1, times 2 is 2. 2 to the -1 is 1/2, times 2 is 1. 2 to the negative 2 is 1/4 times 2, that's 1/2. So now 2 to the 1 is 2 times 2, we're at 4, and here we get an 8. So let's go to graphing these. 0, we're at 2, 1, we're at 4, and 2, we're at 8, pretty much approximately up here, and then we're at 1/2. Okay, so, oh no, 1 first, and then 1/2. So what's happening here is with that 2, it's actually like condensing it in here. So it's being pushed in. And what it is, those are little arrows meant to say, it's not necessarily that it's moving. I suppose I shouldn't do them. That gives the impression it's just moving off to the side. When what's really happening is it's being stretched up. Stretches by a factor of 2. So it's like most of this stays close to the same, but then it's being pulled up this way. And like a rubber band stretches up. Okay. Now here, in the 1/2 one, the opposite's going to happen. Okay. So what'll happen here is we'll get a 1/2, and then it's going to go on the outside of it. Because it's being pulled aside, we call shrinking it. But it's being pulled out that way. So we'll write it as shrinks by a factor of 1/2. Factor simply means something you multiply by. As a verb, it means to multiply. Okay, or to undo, sort of undo. Well, we won't get that far. That's not part of this lesson now. Yeah. This one becomes very, very simple now. It's simply reversing, flipping it, reflecting it over the x-axis. So in this case, we would just do the exact same thing as if it was a mirror image. All right. Reflects, flips over the x-axis. And then, as you can imagine now, this one's going to flip over the y-axis. Okay, so reflects over the y-axis. Okay, so that means it really matters where the negative is placed. So notice that these two go together as both of them being negatives in front or with the x. These go together, and they stretch or shrink based on whether it's, this is called the A. So it's in terms of A, B, X is how we like to call it, where B is the constant number here. So in this case, A is greater than 1. Here, A, whoops, let me do 0, A, and 1. A is greater than 0 and less than 1. It can't be less than 0 because then it would be this kind of situation, a negative. And then that would do something different. That would reflect it. And back here in the first page, these two go together because it's up or down, and it's simply the plus or the minus. And then these two go together because it's left or right, and it's with the x. So these are with the x, plus or minus, and these are outside of where the x is, plus or minus. we'll take a look at compounding interest. So there are a couple of formulas to use. This one compounds interest. Okay. It can also be where you're losing money, and that would be a negative inside instead of a positive. If you continuously compound, you would use this. So what we're going to look at here, you need A, the initial amount. Oh no, A is the amount after t years. P is the initial amount, principal, and I like the term initial amount as well. And then you have R for the interest rate and N for the number of times compounded in 1 year. Remember about the interest rate, not percents. Change to a decimal. I think I need to write that a little bit clearer, and I'll do that by increasing the size. Okay. Not percent. Change to a decimal. That was very important. And on the next one, we have almost the same things. We have the amount after t years. We have the original amount. We have the interest rate. And we have the amount of time. We don't have a number of times. We don't have an n in that one because it's continuous. And in this formula, we use E. E is approximately equal to 2.71 and something. I don't know the exact number, but I don't have to. All calculators have an E key. So investing invest $1,000 for 30 years at 7% interest rate. And then we're going to look at semi-annual continuous compounding, and then we're going to find the difference. So first, semi-annual means 2 times a year. Okay, and that's going to be the N. So N equals 2. Okay, this is A. This is the R, but we're going to write it as 0.07, not as 7%. And this is T. I forgot up here to put T as one of the important variables there. So first thing we're going to do, we'll do A, and we're going to use the formula, this one here. A is equal to the original amount, 1,000, 1 plus 0.07 rate over how many times it compounds in a year. And then we multiply up here that 2 times a year times 30 years. So here A is equal to 1,000. Calculate what's inside here, and it's 1.035 to the 60th power. So A is approximately 7878.09. So the answer for A is $7,878.09. This is the kind of thing where you have to show the dollar sign or write the word dollars, or it doesn't actually make sense. And that means I also need to put a dot in here very clearly so it makes sense. Now I'm going to draw a little line here, and I'm going to do B. And now it's the continuous compounding formula, and that's going to be equal to 1,000 E, and that rate 0.07 times 30. Put that all into the calculator, and it's approximately 8,166.17. And I'll put the $sign with it there. So that's B. Now, the C asks for what the difference is. Okay, so difference is simply subtracting those amounts. Okay, minus 8166, which actually means I should have put the 8166 on top. So I'll get a negative, but then I can throw the negative out. I think I will go ahead and just go back and fix this though and put the larger one on top, since the difference between them will be a positive, since it's not saying which one's larger or smaller. It's simply what's the difference between them. And the difference between them is $288.08. And that's approximate because those numbers in the first place were approximate too. One example of this. Let's take a look at the next page and just do it again. And it's really the same idea. You'll see it's the same thing. This is a good one for you to do yourself, and stop the video for a moment, go do it, and then come back to it, restart it, and I'll be doing the problem. Okay, thank you for coming back. A, I guess it's lowercase a, that's what it's showing there. And then we have the formula A equals P, 1 plus R over N, N times T. Look at it, $300, 20 years, 8% interest. Okay, and quarterly compounding is 4 times a year, so N is equal to 4. So the amount is the 300, 1 plus 0.08. I was careful to change it. And then the 4 times the 20 years. So when you multiply all that and work it out, it comes to $1,462.63. Now for B, we're going to do the compounding one, P-E-R-T. A is equal to 300 E 0.0820, and that's approximately 1,485.91. Now let's go ahead and find the difference here. 1485.91 subtract 1462.63. That's not so much of a difference here. 2328, which, let me first mark these up to show that they're the answers for each of those. And what we see here is the only real difference between them is the 20 years. So quarterly compounding, continuously compounding doesn't give you a huge difference, but overall it still gives you an interest if you didn't do any compounding, for sure. I suppose we could have done, well, we would have had just $300. So these are still large, good increases, but might as well do continuously compounding, especially if you look up here. Look at how much difference it makes to have 30 years instead of 20 years. If it was 8%, it would be an even bigger difference. Okay, so I hope that helps with understanding these formulas and using them. So people definitely need to know these formulas here and understanding the graphing transformations and equation transformations for exponential functions. Well, thank you for watching and listening.